My name is Harry Tormey, and today I'm going to be giving a talk entitled When to Go Native Over JavaScript. The context for this talk is, of course, React Native. Now, before I get into my talk, I want to give you some background information about me so you can better understand my perspective when I talk to you about this important topic today. So first and foremost, as you might have guessed from my accent, I'm not American. I am Irish, but I don't come to you today from the rolling green hills of Ireland, no. I come from San Francisco, where I've been working for the last 10 years as a native software engineer. Native software engineer, what does that mean? Well, when I came to San Francisco first, I got my start doing cross-platform desktop application development for Mac and Windows and C++. Spent a few years doing that, and then I went on to do Android development, where I was mainly working in Java and C++ for some startups. I then went on to work at some big companies. I spent nearly 2 years at Apple working on iOS and Objective-C iOS applications. So again, Objective-C and C++. I then went to work at Facebook, where I spent 2 years working on the main Facebook app in Objective-C++. Fast forward to today, and I work where I run a contracting/consulting company that specializes in mobile, mainly native iOS, Android, and most pertinent for today's talk, React Native. Well, what is this a talk about? Well, I want to build on my native experience to tell you how native code like Java, Swift, Objective-C can impact the way that you build React Native applications on a day-to-day basis. In order to do this, I'm going to look at 3 areas where you'll need to think about whether native code is present or whether you should be using native code. And these areas are tooling, third-party libraries, and when you actually have to write native code yourself. Now, in order to explore each of these areas, I'm going to either give some examples or sample code that illustrate an architectural point I want to expand upon. Now, my goal with these examples or sample code is not want to be prescriptive. I'm not trying to say to you that there's one true way to write React Native applications, because there's not. There's a lot of them. I just want to help you understand the architectural consequences of your decisions, save you time, and hence save you money. So the first area that I want to look at is tooling. And the first tool that I want to look at is one of my favorites, which is Expo. Now, if you're at Brent's talk yesterday, you're probably familiar with what Expo is, but just in case, I'm going to briefly recap. So Expo is kind of like Ruby on Rails for React Native. It's a suite of tools that are built on top of React Native that allow you to get up and running, building React Native applications, even if you've never installed the native toolchains on your computer, aka Xcode or Android Studio. So why do you do this? Well, with Expo, you download the Expo XDE, you install the Expo app on your iPhone or Android device, and you start editing in your editor of choice, and you can run it. A QR code will come up. You can scan that QR code with your mobile application, and your React Native code is there. You can edit, the changes will show up. It's super awesome. When it comes time to release your Expo app to the App Store, Expo will spit out the binaries for you that you need for the Google Play Store or the Apple App Store. Expo also handles push notifications and over-the-air updates. It's awesome. So what's the deal with native code in Expo? Well, let's say you want to use a third-party library, like, say, the GitHub Mobile SDK in your application. The GitHub Mobile SDK wraps some native code. You can no longer use that QR code scanner. You cannot have your changes with the GitHub SDK, the third-party library that wraps this native code, do the over-the-air updates. You have to do something called detaching from Expo. It spits out the Expo SDK, and you have to handle building and distributing that app yourself. This can be quite painful if you'd be depending upon Expo for over-the-air updates or to do push notifications. It's something that you need to think of in advance before you use Expo, or at least factor in that at some point in the future you'll need to diverge from using Expo and manage this yourself. Also, if you want to write native code, let's say, for example, you're really stoked about iOS 11, AORKit, all these changes to navigation controllers and stuff like that, and you want to use some of that in your application. Expo does not support pushing native code to your app. Again, you'll have to detach and build and distribute it yourself. Just a point to think about. The next awesome tool that I want to talk about is Code Push from Microsoft. What does Code Push from Microsoft do? The TLDR for Code Push from Microsoft is it's a cloud service that allows you to do over-the-air updates with your React Native applications. It's really awesome. I use it with several of my clients. I think Code Push is a great product. But once again, If you release an application to the App Store, or you've distributed it with enterprise distribution like I have, and you want to add some changes that involve native code, like again, add a third-party library that contains native code to that application, you can't code push that. You need to do another binary release, submit that to the App Store, get that released, and then do a code push that only targets that. Just something to keep in mind. So building on the examples that I've just given, the next area that I wanted to talk about is third-party libraries. Now, as you can see from the previous example, the mere presence of native code in a third-party application can have a big impact in the way that you build and release your React Native applications. So with third-party libraries, there's one category of third-party library that I particularly want to dig into, because I think it gives a lot of new engineers to the React Native ecosystem and experienced engineers to the React Native ecosystem a lot of confusion and pain. And that category is navigation. So let's say you want to build a React Native application that handles deep linking, or has a navigation stack, or has tabbed navigation. Well, you probably want to use a third-party React Native library to handle that. And the next logical question that you'll ask yourself is, which navigation library should I use? Now, I want to pause the talk here because I think Javier brought this point up yesterday, but can you spot which one of these navigation libraries have native code in it from the name? It's kind of confusing. Think about that and think about the previous point I made about code push and expo. This is something that can be quite confusing. But anyway, returning to my talk, which navigation library should you use? What's the difference between all of these navigation libraries? Well, it turns out that the answer to that question is rather complicated. Some of these libraries have features that the others don't. Some of them have like APIs that are really different in the way that they compose routes and scenes. But for the purposes of this talk, I'm going to divide all of these libraries into two broad categories. Those libraries that are native-based and those libraries that are JavaScript-based. So what's the difference? Well, native libraries wrap the underlying navigation system of the operating system that they target. So in the case of iOS, that's UI navigation. So React navigation, native navigation from Wix and native navigation from Airbnb are both wrapping UI navigation on iOS. The JavaScript navigation libraries, on the other hand, attempt to replicate the behavior of the underlying operating system or not in transitioning screens and handling routing and so on and so forth. So we're going to explore this concept a little bit more through an example app that I've written. This example app, I implemented it twice, once with a JavaScript-based navigation stack and one with a native-based navigation stack. And those two stacks are, the JavaScript one is React Navigation, the native one is React Native Navigation from Wix. You can find both the source code of these apps on my GitHub, github.com/hkl. So what does this application do? Well, it's a single-screened application with a navigation stack that uses Redux for state management across screens. Each screen in the stack consists of the following: a text label that shows its index in the stack, 3 views displaying randomly selected colors, a random animated picture of a cat that's selected from a list, and 2 buttons: push new screen, which pushes a new screen onto the stack, and update all screens, which basically dispatches a Redux action that causes all of the screens in the stack to select new random colors and a new random cat picture. Kind of a contrived example, but you'll see why I did it in a minute. So let's see what this looks like in action. So as you can see, I'm pushing a new screen with this button. It's coming on. I'm now updating the screen. The previous screen's values are different. That's kind of what it does. Funny cat pictures are awesome. So how are we going to explore this? Well, I'm going to explore this from the point of view of a native developer, which is via Xcode. So Xcode has this really cool feature where you can basically pause the simulator and you can look at the view hierarchy. You can see what's being rendered by UIKit, the rendering system of iOS. So what we're going to do here with the JavaScript-based navigation stack, React Navigation, which is included with Expo, is we're going to push a couple of screens. We're going to pause the simulator, turn it sideways so you can see the view hierarchy, and if you're a native developer, you'll notice something unusual. And that thing is that all the previous screens are being rendered, not just the screen that's on the top of the stack. And the significance of this is going to become apparent in a couple of slides' time. So let's do exactly the same thing that we did before, but with React Native navigation, the native navigation stack. So once again, we're pushing a couple of screens, we're pausing the simulator, and we're going to view the UI hierarchy. And we're going to notice something immediately different when we turn the screen sideways. And that thing is the previous two screens are not rendered with the native navigation stack. So why is this? Well, in order to explain this for iOS, we have to kind of take a step back and look at like an architectural point about React Native and iOS in general. So with iOS, each screen that you have has a view controller backing it, and that view controller is kind of like the native equivalent of a React component. It has its own lifecycle functions, but it also has a view that's associated with it. So React Native by default just has one view controller, or I think it's an activity or a fragment on Android. I'm pretty sure it's an activity, and it basically hangs all of the JavaScript off of that view. So for the JavaScript navigation stacks that are attempting to simulate what a native navigation stack does, they hang all of those views off of a single view. So why does this matter? Well, this matters because on Android, this completely breaks accessibility in certain scenarios. So if you have, on Android, two screens on top of each other with a navigation stack with any of the JavaScript navigation libraries, like we tested this with React Native Router Flux. If there's text in the first screen that's not visible on the second screen, and you touch it on the emulator with accessibility, it will read the text behind it. So this can break your sign-up flow for blind people. There are ways to work around this, but my colleague Erica Cooksey, who's a really, really talented Android engineer, she took the time to write this up and put it up on product panes. You should upvote this. Now, I bring this up because this is an example of one of the subtle things that can come up when you try and simulate a navigation stack rather than completely replicate it. So apart from that, what's the difference between these two approaches? And one thing I would say is native feel. So native navigation and React Native navigation, they make view controllers a first-class citizen. So in order to, rather than having just one view controller with the views hanging off of it, they make it so that they have like multiple view controllers on iOS. And this allows them to have exactly the same navigation transitions and behavior that a normal iOS application would have. So this results in things feeling exactly the same, especially when Apple changes things with the navigation stacks like they have with iOS 11. The JavaScript equivalents of this will have to kind of rush to emulate any of these little quirks that kind of come up so that it feels exactly the same. The other kind of consequence of this is performance. So if we look at the perf for React Native navigation versus React navigation, there is less views being rendered for React Native navigation, and the memory footprint from our testing tends to be a little bit lower. A minor difference because this example is a little bit contrived, but something that you might want to keep in mind if you're building more complicated apps that have complex navigation hierarchies. So in summary, Native Libraries pros are performance, and it feels and behaves more natively. But there are some pretty huge cons. Remember again, the reason why it's important to think about this is if you have selected Expo or Code Push and you decide to switch your navigation stack out like we did to use a native one, you're going to have to plan around this with your release strategy, or you might have to completely switch up the way you do your tooling. But again, it's like, adopting these things is a real pain in the ass. So we migrated over from React Native Router Flux to React Native Navigation. And, me and Erica are both experienced native engineers, but all of these native navigation stacks, they're kind of on the bleeding edge, so the documentation for the latest version of them may not be great. You'll run into linking and building errors, and just the default setup where you have to edit your app delegate, do a bunch of build settings, it can be tricky and annoying to deal with. So again, if you don't have native developers in your team or people who can jump in and help you out, this can be problematic. Also, iOS and Android, their navigation systems, the way that fragments behave in memory versus view controllers in iOS, it's different. So if you're not prepared to invest in having some native knowledge, this might not be a good idea for you. Anyway, moving on to my last section, when you actually have to write native code yourself. Now, in order to illustrate this point, I'm going to refer to an app that I wrote for one of my clients. And my client is Ease, a medical marijuana company in California. So medical marijuana is not legal at the federal level. You cannot send medical marijuana through the post, Amazon style. So what Ease did to get around this was they kind of created the Uber for weed, if you will. So Ease in California have basically this software that they license to depots. The depots employ a fleet of drivers. Each of the drivers has a little suitcase of weed in the back of their car and marijuana products. And they basically poll the server with their location for security reasons, but also so that if you're sitting in your office and you're like, oh man, this code, I'm so sick of updating these React Native libraries. I need to get some like relaxation. They will find the driver that's closest to you and map your order to that driver. The driver will come up, check your ID, and they will deliver your product to you. And you can continue developing React Native stress-free. So who wants to see me order some weed? Yeah. Don't tell my mom. I'm not sure she'd be happy with that. But anyway, we're ordering some espresso beans. This is the development server. I'm not actually having it shipped to Gantt at the Armory. Or maybe I am. OK, so then we have the simulator up here with the driver app. You're going to see the order come true soon. And there we go. So you can look around at the order here. Basically, the driver uses Waze or Google Maps to actually navigate to you. But the question you might be asking is, like, Harry, why can't we do this in JavaScript? And to answer this question, I created a little example app. The example app is a React Native app that basically posts your location periodically. There's a little Node.js server that's going to be running in the background that basically prints to the console all the posts that it gets with your location. And it looks something like this. Is that running? Oh yeah, there we go. And you can find the source code, once again on my GitHub, hgale. Don't copy and paste this code into your Portland-based illegal marijuana delivery app or whatever. There is bugs in it, which I'm going to discuss. There's also pull requests on that fix these bugs. But you might be saying, well, Harry, why can't I just use a library like poll or setInterval and periodically do a post request with this? Why will this not work? Well, that has to do with what this fundamentally is. It's a little computer with a limited amount of battery life. If every single application that was backgrounded could run forever, this would get really slow, the battery life would suck, and you would hate life. So what do the operating system vendors do? Well, on iOS and Android, basically the operating system decides when to suspend and when to kill your applications. And a large part of when it decides to do this is if your application is running in the foreground or in the background. And an important reason that I bring this up is I think a lot of you guys are coming from a web background. That would be kind of my suspicion. And so if you're doing web development, for most cases, not everything, Safari, Internet Explorer, whatever you're developing in is the kind of environment that your user sees. The simulator is not that. So if you go back to the slide that I showed you before, the little video, you'll notice that I kind of background that example app and it continued posting. On the device, it will not do that. So when you're testing anything that has to do long-running background tasks, you need to test on the device. You need to test on the device with the app background and the screen locked. Locking the screen actually changes the behavior of this as well. You also need to test the app backgrounded. So on iOS, about 8 minutes should do it. Android, 10 to 20 minutes. And you also want to test on a lot of different Android devices. I know fragmentation is a bitch. And you also need to test with the device unplugged and not on Wi-Fi. Because if you're relying on network connectivity, that can be affected as well. So always test in real hardware if you're doing this. So you're like, okay, Harry, we don't want to know about this though. We're, crazy React Native developers. Is there not some automagical third-party library that will take all of this, care of all of this for you? And you might be tempted to try something like React Native Background Timer. So will something like this work? And the answer to that question is no. And the reason on iOS why this is a no for our use case is that it's based on something called executing finite length tasks. So what is that? Well, executing finite length tasks is something that Apple provides to kind of give you a single shot of time as your app is transitioning to the background from the foreground to the background to complete a long-running task, like uploading a file or processing some data or something like that. In Apple's docs, they don't tell you how long you actually get with this. From looking around on Stack Overflow, they say roughly about 3 to 5 minutes. But whenever Apple are vague about something like this, it usually means that they reserve the right to change this behavior in a subsequent iOS release. So you really want to be careful about it. And also, I don't know about like Portland traffic, but San Francisco traffic, if you're delivering weed and you're trying to go from one end of the city to the other, it's going to take more than 3 to 5 minutes. And your app is probably going to be backgrounded for that period, and the driver is going to be in Waze. So how do you deal with this? Well, on iOS, it turns out that Apple are like, well, yeah, there's certain use cases that you'll want to run for long periods of time in the background. And so they give you a way to do this. So if you open up your Xcode project, go into capabilities, flip on background modes, you can select location updates. And that basically says, okay, I want to go pull stuff in the background. Now, whenever you request a permission like this that could compromise the privacy of a user, you have to actually explain that to the user. So you do this by basically editing your plist and specifying the string that gets shown to the user when you ask for that permission. So okay, you go and you do that. Then you need to kind of like sprinkle in some magic Objective-C or Swift code. This code up here, don't try to read it. It's just basically asking for the location permission. I stuck this into the app delegate because this is an example application. So if you do all this voodoo, will this work? Can you just use the poll library or set interval and continue on with your business? No, you cannot. So Brent Fatna from Expo wrote a product pane on this, but the TLDR is that React Native timers don't work in the background. So what you have to do is you have to write like a bunch of lovely looking Objective-C to basically kick off a long-running polling task in the background. So again, like once you've done all of that kind of permission stuff and do all of this stuff, I just use NSTimer here to continuously poll the server because we don't actually care about the GPS coordinate. We just need to turn this on and off for our particular example. So some things to note at this point. Despite having to do native code for this one little scenario that's kind of a bit weird, 90% of the driver app is JavaScript. There's some platform-specific stuff, but most of it is this. We do use code push with this, but we have to be very cognizant every time that we ship some native code with this. We tag it to the particular binary release that we're doing. So the other thing to note as well is that the drivers who are using this application are employed by the depots. So they don't mind having their battery life destroyed by this approach. And it's mainly done because my client insists upon it for security reasons. There are nicer libraries, like there's one from TransistorSoft and there's one that use kind of differences in location to actually poll and wake up your app. That's a much more consumer-friendly approach. This is something that's a really weird scenario that's particular to my client. Most of the time you can get away with not writing native code. So after finishing this example, I have to say thank you very much to Ease for allowing me to show this to you and to release some of this code. They also paid for me to come up here. They paid for my flight and my hotel. They've been an awesome client for LaunchStore, so thank you very much to Ease. I also want to say thank you so much to all the Infinite Red folks. This is the first React Native conference on the West Coast. I'm so honored to speak here, and thank you all for listening to me. One more thing, sorry. I wanted to get a slide in about performance, but I had to kind of cut down my talk a little bit. If you go to my Medium blog, I have an article on it at launchstore.com that talks about how to solve some performance issues with native and when you don't have to do that. You can also contact me here if you have any questions or you need help with anything, and my Twitter handle is htormy. Thank you for listening to me blather on. I really appreciate it.